Question number 12. A young double slit experiment consists of two narrow slits separated by 0.06 meter. We have monochromatic light, and then we have this type of slit. So the D value is already given for this one. They are separated by 0.06 millimeter, and consider this is a mirror screen, not screen. So we get constructive and destructive interference on this one. So after the diffraction grating, okay, so we have constructive, destructive, then constructive, destructive, constructive, and so the middle one considered to be n is equal to 0, then 1, 2, 0. Start from 0, goes to 1, 2, 3, and so on to the right as well as to the left direction. Okay, so having this in mind, we have to consider the given value, which is D, spacing, which is equal to 0.06 millimeter. Can convert into centimeter, which is equal to our meter 6 times 10 raised to minus 2 millimeter or minus 3 centimeter. It's possible to write in such form. Okay, so the other given value is the distance between diffraction grating and the screen, which is equal to 1.2 meter. It's already given in the question. Okay, so lambda, which is the wavelength, is 563 nanometer or 563 raised to minus 9 meter. Okay, so these are the given value. Now let's go to the formula, which is n lambda multiplied by d sine theta. This is the formula for diffraction grating. Okay, so before that, we have to know that tan theta is approximately, for small angle less than 10 degrees, is approximately sine theta. And this approximately theta value, and this is approximately is equal to the opposite side of adjacent, which is considered x is the opposite and L is adjacent. Okay, so this is x, which is both of same mathematics. This one is x from n is equal to 0 to n1, n2 considered to be x, and the distance between the diffraction grating and the screen is considered to be L value. So with this, then theta is x divided by L value. So this is L, and this one is x, and this one is theta. So for this small angle, we have x divided by L. So having this in mind now, let's replace the formula wherein lambda is equal to d sine theta, and lambda, which is equal to d sine theta. Instead of sine theta, it's possible to write x divided by L value, which is d x divided by L. Okay, so now the only unknown value is x. We have n lambda and L value. D is known, so x is equal to n lambda over L divided by d. So x is equal to n lambda L divided by d. Okay, so x is equal to n is 4 by 2, 3, but for now it's 4. Lambda 563 times 10 raised to minus 9 meter divided by the distance between the screen and diffraction grating is 1.2 meter divided by d value, which is 6 times 10 raised to minus 2 millimeter, and times minus 1 in terms of centimeter. At times there is to minus 2 in terms of meter. Now it becomes meter. Minus 2 meter. Okay. Therefore, so multiply them together and using calculator, and final result will be x is equal to 450.4 multiplied by 10 raised to minus 4 meter. So when you change into centimeter, it becomes 450.4 times 10 raised to minus 2 centimeter. So this means 4.504 times the centimeter, or is approximately equal to 4.5. And it is 4.5 centimeter. Therefore, the answer for this question is D. Okay, let's go to the next question. Number 13, an electric dipole consists of a negative charge Q placed at the point with the coordinates minus 2, 2 and plus 2, 2, one positive, the other negative. Okay, which means that we have the y-axis and we have the x-axis. Okay, so we have the electric field in horizontal direction, which is parallel to x. So the direction of electric field is, it was given that in positive x direction, which is described in the equation. So we have a positive in the left side and negative in the right side. That is the expression of this one. Okay, so at point 2 we have a plus charge Q. Okay, and at negative 2, 2, here we have negative charge, negative 2 minus 2. Okay, so okay, this is minus 2 and this is minus charge, minus Q. X is minus 2, y is minus 2 as well. We can always find the force which is applied on the charge. So let's start from the positive Q. In positive Q, which is the positive is the left side, so the force is in the right direction. The electrostatic force in the right direction, and the attraction between two charges downward. So the net force is this way. So when you look to the second charge, which is minus Q, so it attracted in the left direction, and by plus Q upward, so we have this net force. This is the net force for minus Q, and this is the net force for plus Q. Okay, in general, so there is rotation. Some rotation will be there. So it's an implication that the angle theta is decreasing. There is a decrease in angle theta due to the rotation. The angle it makes with the horizontal x-axis. Okay, so this is the theta value. So considering the x-axis and the y-axis, let me show you. We have one axis which is upward like before, which is the y-axis, and x-axis, and the two charges are aligned like this one, plus charge and minus. This is theta value. So there is, due to the rotation and the electric field, so if we have first theta, then it goes to theta 2, so theta 1 is larger than theta 2, and finally they will align with each other. So having this in mind, it's possible to answer the question. Okay, so the first one says A, the field rotates dipole in the direction of decreasing angle. That is correct, until the dipole become parallel to the field. This is the correct answer. The other is not correct. B, the field rotates in the direction of increasing angle theta. No, it's in the direction of decreasing. It is C, it is in positive translational rotation. No, it's not in equilibrium. It travels in the direction of decreasing. No, it cannot travel in the direction of the electric field. One is positive, the other is negative. That's why it cannot travel. So A is the correct answer. Question number 14. The electric potential at a distance to centimeter from A is minus 1.6 raised to minus 10 coulomb when charged. So we have to find the electric potential. So let's apply the formula for electric potential. V is equal to K multiplied by the charge Q divided by the distance R. Okay, V is equal to K is 9 times 10 raised to 9. So meter square over coulomb square multiplied by 1.6 times 10 raised to which is given already minus 9 coulomb divided by distance 2 times 10 raised to minus 2 in terms of meter. It's given in centimeter. Okay, 10 raised to 9 minus 9, they cancel out. Then multiplying this one, we'll get V is equal to it's around 7.2 multiplied by 10 raised to 2. So this is equal to minus 720. Therefore, from the given alternative, the answer will be D. Question number 15. Two resistors R1 and R2 are in parallel to each other and their combination connected in series with 2 ohm resistor shown in the figure. So potential difference, so the potential difference across R1 will be going to be calculated. Okay. So we have 2 resistors. First, let's find the total resistance for a parallel connection. The first one is 1 ohm, and the second one is 4. They are connected in parallel. So R total is equal to 1 over 1 ohm, 1 over 4 ohm. Yeah. Common, we have 4 plus 1. So this is equal to 4 over 5. R total is equal to 4 divided by 5 ohm, or 0.8 ohm. So this one, which is 4 over 5, is connected with the second resistor. The second resistor is given, which is 2 ohm, and they are connected with the source. The source is already also given, which is 14 volts. Okay, so let's find the current. Current is equal to voltage, which is 40 volts, divided by 4 over 5 ohm plus 2 ohm, because we need to find the total resistance. So this is 2.8, therefore we have 40 volts divided by 2.8, 0.8 plus 2, which is 2.8. So 40 divided by 2.8, this is equal to approximately become 5. So I is equal to 5 ampere. So having the current, which is 5 ampere, it goes in 2 resistors. Therefore, the potential difference across R1 should be calculated. We know that R total is found to be 4 over 5 ohm, which is 0.8 ohm. So the voltage across them is equal to 5 ampere multiplied by 0.8, which is equal to 4 volts. So this is 4 volts passes through each of them, and the rest voltage, which is 10 volt, passes through 2 ampere. So from this, you can see that on these 2 resistors, we have the first resistor we have the second resistor, and this one is the third resistor. We have 14 volts. Here the current it passes through is 5 ampere, and here is the current is the same. So here we have 2 ohm, so 5 times 2. Here the voltage drop is 10 volts, and here we have 1 ohm, and there is also another one which is 4 ohm. So 5 is 4 volts. I'm saying 5 times 4 is the current will be distributed 5 ampere for the first one and the second one. There voltage drop is here in both of them is equal to the same, which is 4 volts. So we have 4 volt here, the same, we have 4 volt here. The current is 4 divided by 1. Here we have 4 ampere. Here again 4 volt divided by 4, which is 1 ampere. So 4 ampere plus 1 ampere is equal to 5 ampere, which is 2. So the answer for this question is equal to